All right. Functional expressions. We're going to have to do it ad hoc a bit without the videos, but let's do it. Local versus global scope recap, hoisting recap, functional expressions and anonymous functions. So we had that video there, and really what that was trying to establish was that we have the concept of global scope and local scope. If you don't already know, we can use REPLs, by the way. So in our lab, you may feel that what is going on here with this? You may not need to use that HTML file all the time. You can just do your scripting file now. Now that we know a little bit more about JavaScript, we can actually work in one of these playgrounds directly. We don't really need that web page unless you feel like you need it. You can actually start scripting in here. It would mimic a server. It's, as you can tell on the left side there, it's using Node.js. We will eventually get to Node.js. Okay, I'll try that in a bit. Yeah, so you can do this directly, and then in the lab, you can copy your script and just submit the script once you know it's running. I can quick glance at it or throw it, copy paste it in here and run it. But then we don't have to worry about refreshing the browser all the time, and it's a real pain, right? When we want to just learn, just scripting or programming, we shouldn't really have to deal with the browser to trigger the compiler if we're not using UI elements. So if we're writing script here, this is a nice little panel where we can just focus on our coding. Now, mind you, there's some other features of the browser, but we'll get to that. So really what they're saying is local scope may be some big variable here, like we established. It could be something like, I don't know, tax rate. Something very descriptive we might use. We haven't learned constants, but it could be something that doesn't change. We may have a bunch of stuff in there. Maybe we have something there called counter, which is an awful global parameter. And then we may have our functions that inside of our functions, we may have some global scope inside of there. Oh my God, I'm already forgetting here. Add counter. Been doing some JavaScript all day. I gotta get the syntax, take it back a little bit. All right, so inside of here, I may have something called a local variable that is called counter. And inside of here, I may do some operation to it. I may have some logical operation going on, and maybe inside of here, I do some increment to counter, and I added +1, and then I console log it out. Say local counter. I don't know about template literals yet, so I'm gonna just use the old school string concatenation, and then that would output my counter. Right. This one right here is a global one because it's on the outside. Everything can see this and affect it. Ideally, this is the container of a function. Inside of that is local, and then if I try to invoke it, let's try it. So remember, we need to invoke our functions, add counter like this in order to trigger it. Otherwise, it won't work at all. Thank you. I will try to run that. Let's try this out. So it said count. So this is really good. So if you were using the browser and the browser is not telling you what you're doing and you don't know what's going on, this will actually give you some good errors here. So it's saying right here, count is not defined. That's some good feedback. So right here, this thing right here, it doesn't know what that is. So it's expecting counter, right? So now if I run it, so the expectation now is that this local variable is being incremented. I could increment it I could increment it by 5. If I try to do the same output here, outside of this, after the execution ends, the scope is closed up. Anything inside of it is contained within there. Now this is my global scope counter, which I would expect it to be 0, right? So if I run it, global counter is 0, local counter is 5. That's exactly what I want. However, we established that there is a concept called shadowing, which means people can you can overwrite a global scope here. This is what you don't want to do. If you don't define it, it's going to look outside. It's going to affect this counter here. So if this was 5, so if I run this, it will say global counter is 0. Okay, well, maybe that it needs to be after this because it's been executed afterwards. All right, so it also matters when you trigger this, right? So if I said global counter, this is before we invoke that function, and this would be after we invoke the function, right? So let's run it, see what happens. Before global counter is 0, so at this point in time, this has not run. This container might as well not even be there yet. It's just basically a placeholder sitting there in memory. Then we actually trigger it, and what it does is it goes ahead and modifies this top level, and then after that it outputs it, and you see it's affected now. So the local counter has now become the global counter. In a sense, we've actually modified that, and that's something you don't want to do. That's something we don't want to do. So what we would rather do is keep our variables contained by assigning them inside of the function, so that when it executes, it'll say, I know what this is. It's inside of my local scope. Therefore, I don't need to look outside of the container. So if I run this again, say global counter 0, local counter is 10. After, global counter is still 0. So we protected this global variable by not overwriting it. So that was the difference between local scope and global scope, and how you could. So a couple things here again. We have some assignments. We have a function with a name that has no parameters, and we have some local scope going on with a variable. We increment it, and then we output it to the console. But we need to invoke it here, otherwise it won't do anything. This is invoking or calling the function, a call. Otherwise, if you don't do that, it'll never execute. When I click run here, you'll see it didn't, before and after, it didn't actually run at all. Use these REPLs. These are really good. REPLs, playgrounds, whatever they're called. I forget exactly. They're called what it stands for again, but it's like read, print, something like that. But this eliminates the whole browser. You don't have to sit there and refresh unless you have a web interface. If you're just coding really quickly, this is a great way to work. And for your labs, you can submit the JavaScript file. If it runs fine in here, that's fine. You don't need to keep creating pages for the sake of refreshing the page to trigger it. I'm fine with this, unless there is a UI task. So that's what we're going to use today in our lab. Right. Carrying on here. All right, so that was going to be the video. I know some people have sent me some good IT related stuff. I'll have to do it in, I guess, some other time. All right, so hoisting again is a bigger idea, but you have to know about it. You may never even think about it after this, but the reason why I want to introduce this is because when we get into expressions, it'll prevent this from happening. So this is where when we define something at the bottom, it throws it up to the top in behind the scenes, which is really strange because let's read it here. In most programming languages, variables and functions need to be declared first before you use them. So hoisting is a JavaScript mechanism where variables and function declarations are moved to the top of the scope, the very top. It does some rearranging when the program compiles before it executes. So the code you write will remain the same, however, the position of the declarations may change when compiled, leading to some very strange things sometimes. But by using something called functional expressions, we can kind of prevent some of that from happening in a way. And it's an expression like we've already done, but we're basically assigning a function to a name in a different way. So the functional expression. So the function keyword can be used to define a function inside of an expression, but you can also define functions using the function constructor and a function declaration. That sounds like a lot. But really what we're getting at here is that we have this counter that we added here, but we can actually give it a variable. We can kind of rewrite it in a way. We can actually rewrite it in this way, where we have var keyword, and we call it add counter, equals to a function. So we're giving it a name, like we're assigning it differently, and therefore the compiler will treat it differently to kind of prevent some of that, those hoisting things from happening. Now, I've worked in many code bases where this is perfectly fine. That's fine, or you can do it in this manner, but to know in behind the scenes what's happening, you might want to prevent that from happening. You might just want to have an expression in this way that's defined in this way. So it's the same thing, you're just kind of rearranging how it's defined. This is no different than assigning a counter to 0, but we're assigning a parameter, this entire function, and then we can call it the same way. See, it didn't actually matter how we did it. Now, like I said, I worked in many code bases where this doesn't matter because there's many different styles to kind of trigger these things. It's just, you may come across this and say, why are they doing it this way? Opposed to the, just a straight function, a name function declaration. So you have to remember that the reason why they may do it is because of that hoisting problem where it kind of throws it to the top. Right. So we can actually look at another example here. Let me see if there is an example to this one here. So this is just saying that the same deal, a function keyword can be used to define a function inside of an expression. Now, when we talk about constructor, we're talking about inside of this parentheses here, you can pass them arguments in. This parentheses here that allows input to be passed in is called a constructor. All right, and you'll see that a lot. But anyhow, the point is this pattern is a little bit different here. In this example, we are assigning an area, and we're assigning a little function to it. It takes a width and a height, and it just does a small calculation, which is width times height. And then we're invoking it in the same way we normally would, and then we get the output of 12. Right, so yes. So it's a different way of expressing your functions. You can declare them, function declaration or function expression. And again, you may go back and forth a lot between these two. So in JavaScript, you can also store functions in variables. You said, so when a function is stored inside a variable, it's called a function expression. Notice how the function keyword no longer has a name, because normally we would have to put the name in a different spot. So this one is a small little example where we have a variable called cat says, we have a function max, and it's gonna go through, we haven't learned this kind of syntax yet, but what it's gonna do is do a little bit of a loop, and it's gonna output meow how many times we ask it to. So that's called a functional expression. So in the same way, I think if we were to go back to our REPL, so we have this add counter, right? So in the same way, we can, right? If we do this, what happens here? It doesn't throw an error. If you notice, I just called it, it evaluated what this is. This might as well be, this could be, this could be counter the value, or if we had a new value called, well, let's output tax rate. So if I say tax rate here, what happens there? Well, it didn't actually do it, but it's if I output that. But if I notice here, it says function is add counter. So it's actually saying that it knows what that is. It's going to evaluate this thing, and it's going to return this whole thing and declare it as a function. And that's just sitting there, meaning I could pass this around if I wanted to now. Now I could actually pass that add counter function around to my program if I wanted to. If I had something very small that was a tax calculation, I could pass that functionality around if I needed to. So if I had a tax calculation for Canadian dollars versus a tax calculation to USD, I could then, based on the person's locale, I had another calculation mechanism. I could then pass, based on which country is inside of that tiny little calculation for USD or Canadian has its own logic built in. Then inside, I could pass that around and use that in whatever calculation you may need. Maybe you would have a checkout and you would need a total. You could do that as well, and you could pass it around. So this is called a functional expression. What's the utility of functional expression? I mean, in which cases is it good to use? Well, if you want to solve the whole hoisting issue, right, where you can declaratively prevent your functions being hoisted in a sense. You're adding them as an expression, and you can call them when you want to call them. They're just registering in memory until you access them. So when the compiler loads it up, it'll take the function as a container, put it inside of a memory location, and then you can call it when you need to, instead of defining it in the global space and doing, it's just sitting there, right, anonymously. Sometimes there can be, some side effects that may happen there. Is it like a generator? No, it's basically like an assignment. So it's an expression. Let's continue. Maybe we'll hit some other points here. If you notice, the function keyword no longer has a name. So it's an anonymous function with no name, and you've stored it in a variable called cat says, and you can access the variable. So one of the things is you can assign a relatively large function to a parameter, and then you can pass that parameter around instead of passing the entire function around. If that makes any sense. You might have a very big function that you might need to pass it to another function, but instead of wrapping the whole object, and it's very dirty actually, it looks awful, you can just quickly say, okay, now cat says with a value can be invoked somewhere else. You can, by reference, pass it around. That's one very good reason why you'd want to do this, if you needed to use the expression in that way. And I can show you that in a second if I don't lose you on that. So if you try to access the variable now, cat says you will see the function returns back to you. It'll return back that function. Right, so we have cat says, we have this, another tutor joined as well, Wanja. She just joined. She probably just joined to say hello. But Lauren also joined earlier, he left. Wanja, you can put your hand up and just say hello if you want to. Hello, okay. She's another tutor as well. You can actually reach out to her as well. She's just probably attending the meeting. But yeah, so getting back to this, so we have a functional expression, and now we have a reference point to it that we can actually pass around. So we're trying to get at the point of that hoisting problem that we were having in a sense, right? So the relationship here is functional expressions and hoisting. So deciding when to use a functional expression and when to use a function declaration can depend on a few things, and you'll see some ways to use it. So one thing you want to be careful of is hoisting. That's the whole thing where I told you it pushes things to the top. So function declarations are hoisted and loaded before the script is run. Functional expressions, like we had just established, are not hoisted. So since they involve a variable assignment, and only variable declarations are hoisted. So the function expression will not be loaded until the interpreter reaches it in the script, which is what you want. That's the behavior what you want to have happen, right? So if I have something down here that could be, let's just say it is, I don't know, modify, I don't know, modify, delete, okay. Clear counter, right? And we have something like this here. Inside of this function here, it might actually clear the counter. If you guys can mute your microphone in a sense, please, thanks. So this whole thing here will be thrown to the top. And in a way, if this could be, now there's a concept of self-executing self-executing functions that will run right away, which we don't want, because if this actually ran right away, it would be, number one, it'd be thrown up to the top here when the compiler loaded, and then it would go and it would mess up our calculations, right? So in a way, if it was a self-executing function, if I had it correctly executing, it would run right away, and the compiler would just execute it without any control of the programmer. And that would modify and side affect your results. So you would want to, you don't want that to happen. You want, if you want it to stay in order of execution, you could then assign it a variable, and only then would it be called when you actually access this, right? So the point is, this will register in memory until you call it. It won't side affect anything by potentially being thrown up to the top of the execution and then triggering something or modifying some state or doing something you don't want to do. So you have control this way, so that when you need to trigger it, you can trigger it. So it kind of prevents that whole hoisting thing we talked about. So if you don't really care and your functions are pretty clean, then you may not want to use it in this manner. But if you see it in code bases, you may now have an idea of why they were doing it in that way. They maybe wanted more control over their functional programming. And again, hoisting was this graphic here, wherever it was, right here. This variable gets moved to the top of the compilation, and so you can call it before it's even defined, which, you know, is just really strange. But again, a higher level concept. And to answer your question, yes, go ahead, Shivam. Sorry.
Hi, Mike. Thank you. I'm not very clear about hoisting, but let me try to explain it in the layman language, and perhaps if I'm missing something, then you can point it out. So is hoisting kind of like loading a gun and keeping it, and even though the whole program might run and the gun might not be fired, but because the gun is being loaded, an additional memory and processing is taking place. So in order to prevent that, we declare functions in the way that you showed. Is that what it is? I mean, or
I think you got it wrong. A functional expression is like loading the gun, and then when you trigger it when you want it to go off, right?
Yep, that's like firing. So
yeah, so that's the functional expression. Hoisting basically will try to, you know, put the bullets up on the top before you even establish that you have a gun. It's not a great concept, but it's basically gonna try to you can basically put the bullets up. You can basically declare it up front, and it'll try to move things around on you. Whereas if you protect it with a functional expression, you only trigger it when you want it to trigger it. You protect it from being hoisted or going anywhere. You leave it locked down until you decide to call it. Whether or not you call it or not is up to you. It's protected inside of an expression. So it won't misfire on you unless you fire it, it won't misfire. The other way, basically some weird side effect can happen and it may trigger a misfire or,
okay. So Mike, the example that you showed of add counter, in which the line was counter equal to 5 instead of var counter equal to 5. So if that function is declared like in a normal way, then it will be hoisted regardless of whether it's called or not.
Yes. So you could in normal, it kind of tries to put it in a way that normal programming languages compile, so that if you define something way down on the bottom here, you know, but if you were to actually way up in your code, you have thousands of lines of code up here, and you try to access something, right? You try to call counter. Someone might say, well, I don't know what that is. I haven't declared it yet. So what is this thing? You can actually call that in a way, right? It'll actually, if we go back to that diagram there using a simpler version here, we have a variable called x, way at the bottom of our script. A declaration that happens at the bottom of our code will be moved to the top of the code where it's being compiled before it executes. That's very strange. Why would you want to do that, right? So this, in a way, and if you see it's doing some by moving it around, it can execute in a different way, giving side effects that you might not want. Again, causing more problems, right? If you want to protect it and not have it trigger a misfire, you give it an expression and it'll only evaluate when you call it. So therefore, it doesn't get rearranged when the compilation is happening. So,
okay. So the best practice is not to leave any declaration just hanging there by itself. Always assign it to someone. Whether we use it or not, that's a different question.
yeah, I
But
mean, it is
always,
best practice, but I can tell you now, the current workplace I work at, they don't necessarily do all this all the time. So it is best practice, but like I'm saying, you will see a mixture of many different ways. I'm just trying to explain to you the differences between a declaration and an expression. But you will see functions defined in many ways. So it's good to know them all and why they do it that way. So I like to use functional expressions every time when I code, but like I said, you may not see that.
and Mike, is this specific only to JavaScript, or is
This
it
is
applicable?
very specific to this mechanism. Like I tried to point out, this is one of the quirkiness of it. It's very quirky. It's
Okay,
very
thank
high
you.
level. Yeah,
Mm-hmm.
it's very high level. It's very quirky. I probably lose a lot of people in this, but this is the language itself. Is some of the weird parts. Like they have courses on the weird bits of JavaScript, right? If you start out in Java or C#, this type of thing doesn't happen. It doesn't make any sense. C# or Java will say if you declare something, it needs to be declared up top where I know where it is, because when I hit this variable x, if you haven't declared it, the compiler will bark at you. It's very ordered, structured very orderly. JavaScript is quirky. JavaScript is strange, right? And you're going to have some of these strange bits. I might as well explain them to you now, even though I may lose some people. Just know about it, because when you see an expression, you'll know why they're doing it. But anyhow, it's a high level. It's a high level thing. I don't expect, yeah, I don't expect everyone to grasp it in the beginning, but I might as well tell you about it because you will see it quite often. Yes. So I'm gonna try to, yeah, if I can get my audio video working, I'll play some other videos. Otherwise, I'll drop those videos in the channel and you guys hopefully can do it for homework. So anonymous function. So anonymous function with no name. So this is what is referring to as an anonymous function. We have a function right here that has no name, but I'm assigning it. So if you see a function floating around like this, it has no name. It's anonymous. But I'm assigning this anonymous function to add counter. Therefore, I can pass add counter around by reference, or I can trigger it when I want to. And again, I'm not getting too deep into the technical details of this advanced subject because I could lose everybody. So I'm just trying to give an analogy without really truly losing anybody. But if you're lost, hang in there. All right. Anonymous functions. So functional expressions and hoisting. So we kind of already established this. All functions are hoisted. All function declarations are hoisted and loaded before the script is actually run. Functional expressions are not hoisted since they involve an assignment, and only function expression will not be loaded until the interpreter reaches it in the script, right? So if you have a sequence of your program that needs to run, like maybe you have a page load, at the top of it you have load page, and inside of load page you need it to build a drop-down list, right? Some kind of credit card year, that we did on our lab test, right? But you have a function at the bottom that says clear the list. If it's self-executing, it can be run at the top somewhere. It could be misplaced, so you could load your list, and then right after it, something could clear it. And by the time your page loads, you have no list and you don't understand why, because it could have actually rearranged the interpreter rearranged the script, and then you have this bad side effect, right? So in order to lock something down like that, you assign it, do a variable assignment, give it a functional expression. So when the interpreter hits it, that's when it's loaded in memory, and it only runs when you decide to run it. Maybe you don't ever want to clear the credit card selection, right? But you don't certainly want it to cause some type of side effect on you. Right, so being able to store a function in a variable makes it really easy to pass around by reference, right, to another function. So you can actually then pass things around. So a function then can be passed into another function called a callback. So callbacks, we are going to be really using callbacks when we get to Node.js. Just think of it as like a pointer to a place in memory that you can reference. So you can actually pass it around by name. So we have cat says is a function, but in here, if you notice, it's doing something different here. It's actually passing this function in. It's basically a parameter, and it invokes it inside of it. So we can actually pass this whole mechanism inside of here and evaluate it without having to do it inline, which is really, really, really nice. But it gets a little bit complicated, right? If you're trying to visualize what this is. I had a couple questions there. All right, so I'm sorry, I'm getting a lot of technical. I'll have to go through that. It's how to set up my speakers. Right. So if we go back to the REPL here, let's just clean this up a little bit. If I had something that was a variable called add numbers, X and Y, and I had return, I'm doing a return statement, X plus Y, and I had something called subtract number, two numbers, X and Y, very simple. I'm not checking for the fact that they're strings or anything. I'm just basically taking them as is. I can invoke them all the same. I could say 5 plus 5. Oh my God, sorry. So if you notice here in this REPL, it'll give you a little bit of IntelliSense there. It's nice, and you can just kind of hit enter, and then it'll give it to you. 5 and 5, 5 and 4, what have you. Subtract, enter, I don't know, 10 and 2. If I run this, it should work. No, it didn't work. What didn't it like here? What is it not liking here? Oh, I'm sorry. I'm already thinking ahead here. Look at this. You see what I'm doing? Okay, I was even typing too quickly here. If you noticed, I was in between the two styles, right? Here, if I'm going to assign it, I need to give it an equals, and then I need to give it the function keyword. Now, we don't know about ES6, so the cleaner way of doing this, but for right now, we're doing this long way. So here I'm assigning the function. So now if I run it, it should work for me. Okay, 8, so it only printed out the last one, because that's the last in the execution. Basically, it only does it one at a time right now. So this one is 9, add two numbers, right? 5 plus 4 is 9. 10 subtract 2 is 8, so that works. Okay, but now we have two variables we could pass around. So what they're saying, again, this is a little bit different now. X and Y could also be functions, right? So we could pass functions to other functions. And this is where it gets a little bit weird. You might not do this in your programming. At this point here, you might not be too comfortable with it, but that's okay. So you could do something like this. You could have a total, what have you, it does something, but it's a function that takes function 1, and function 2. And, maybe that just invokes it. Maybe we could do something like this, right? See if it works. So we could just say, let's return two functions. We're just going to invoke them now. We'll see if this works. It may not. And my point is I could actually do something like this. I could actually pass this, add numbers. Maybe I can invoke it in this way. If not, then I'll do it in a different way. We'll try it on the fly here. So let's see if that'll actually work. If that'll take these functions and invoke them and add them for us. No, it didn't like that. Function is not a function, so it didn't like that. So I know what I'm doing wrong. So I can't pass it in that way. I have to pass it by reference. Let's try it this way. Okay, now this is getting really long here, right? So this might look kind of, this might look a little confusing to you. Let's see if we can do it in this way. But anyhow, if it doesn't work, then you get my drift. Let's see. Okay, it worked. Hooray. Live programming there. So it's a little different, and you may not get this right away, but really what I'm doing here is I now have this variable here, and I can pass it by reference. So I pass this function in here as function one. I pass subtract number in here as well, and then I pass the two parameters the two arguments x and y, and then I invoke each one of them, right? So now I'm actually passing them around, where if I didn't give them an expression like this, I couldn't do it in this way. I would have to do something really messy. It would look like this. It'd look awful, actually. You would have to kind of pass it inline like this, which, you know, is awful, really, you know, like, and then I'd also have to pass this inline as well. And now we're getting into like something that makes my eyes water here. Like it makes my eyes water, to be honest, because like I'm passing in functions and I know what they do, but it's not very, I'm sure to you, it's probably, you know, you're like, what's going on here? So by giving it a nice assignment, like that is the same, it should run, let's see. So it ran, yes. So those are anonymous functions being passed to total, which is invoking them. But to me, I would much rather have a nice clean, when I look at this now, I know what it does. I'm adding two numbers together and subtracting them, and I'm totaling them. Very clean in what it does. I understand what I'm doing. And that's why I would use an expression. Another point is I can pass it by reference. If you don't do it in this way, yeah, it's not as clean. With me? All right. let's finish this off. What if add number had a and b as a variable, and how subtract has x and y? Let's see. Okay. Good question. So really, it doesn't really matter if I change this, because these variables are local to that. I could call them, you know, I don't know. Could call it apples and oranges. Really, it doesn't matter, right? So if we had this in the same way, it doesn't matter because these are all local. Now I could x and y. Sorry, yeah, it doesn't matter what the names are once it hits the container, the local scope. Then it is defined within itself. So yes, good point. X and Y does not have to be, you know, they all don't have to be X and Y, right? Because once we hit this function, it's a new declaration right here. You might as well this does the var A equals B. It's the same as var A equals to whatever number. So it's 10, var B equals to 5, right? That's what it's doing in behind the scenes for us. When we pass in arguments, it's doing this for us in this small little constructor, the syntax there, in behind the scenes. And there's a lot of stuff that is done in behind the scenes for us. So that's passing by reference, passing an expression, a functional expression. Wow, so these are heavy topics, right? And if you feel a little bit lost on these, it's better to give them to you now so we can keep going back to it in the next session and the next session, because you will be going back to these all the way through. You're you're going to be dealing with functions and dealing with passing them around. So over time, the more we talk about them, the more comfortable you get with them. So we can pass them around. Concept of a callback. So yes, keep that in your memory bank, call back that term, because we will visit it at some point in time. All right, so inline function. So I kind of showed you that something inline. So a functional expression is when a function is assigned to a variable. In JavaScript, this also happens when you pass a function inline as an argument of another function. So here we have expression favorite movie is equal to this function, and they tried to name it, which is fine. It takes a movie name, console logs it out. So this declaration has two parameters: a function for displaying the message and the name of a movie, which we kind of already did. We already showed that in our example, but this is just a different way of doing it. And if you notice, it invokes it inside of the function. To call it from the outside, we pass in this favorite movie, which if we look up into our compilation, we find it right here. Then we see what it is. It's my pointer. It is this object, this function, and we can pass it by reference. Passing this string goes into the name, and then when we have these two objects together, we can put them together, and we can use name as an argument, and then invoke it. Message function is actually equal to this, so it'll actually display. It'll call this internally and then display it out. So a lot of different playing of names, but it's no different than passing the argument 5. It's no different than passing argument 5 in our, we have here it's called XY, but inside of this function here it's called A and B. Inside of this local scope it's called num and num2. So the names can be different. That's why when I was saying before, when you're programming, make sure that you have very descriptive names. Otherwise, if you have some variable that looks like XYZ and BB2, I mean, what in the world does that mean, right? You cannot, even A and B in big programs is probably not the best. Something descriptive is really good. At least I know with num1 and num2, I kind of have a sense that they're numbers. But yes, so when you're describing your functional expressions and your parameters, make sure you're being very descriptive. You want your coding to tell a story at least. You can look at it. If somebody looks at your script or code, they can kind of understand what it does. Inline function. So inline was basically, as we did before here, this would be something called an inline function. If I did something inline like this, right, yeah, that would be inline, right? Return A. That's an inline function, and you will see crazy JavaScript where they do inline functions because they're just, yes. But to me, that it's anonymous, and that's, yeah, it's not very readable. That's inline functions. But you could have passed the first assignment of the function by passing the function to the movie's function inline. So this is just doing exactly what I said here. So looking at this example here, we pass it by reference, but this is the longer way of doing it. If you feel better about this, I guess you could do it, but it makes for a hard read. So inside of this movie function declaration, so again, the difference between the expression and a declaration is the declaration is function keyword and the name. Otherwise, the expression use that var keyword with the equal sign. So this is a declaration. It takes two arguments: function for displaying the message along with the name of a movie, and then it invokes this function. And this is the call here. This is the invocation, the call. So it calls this movie function right up here. And in line, it does this whole thing. It executes that right up to here. So if you have this curly brace here, again, this is what's kind of tricky. Where does it end? It ends right there. Well, how would I know that? Well, you can see if you have a lot of inline functions, you could easily miss that bracket with the curly brace. And then this is the second parameter. So for me, this is much cleaner because I just have to deal with some assignment. You know, what is the favorite movie? Oh, it's a function. All right. So I kind of understand already what it's trying to do. Whereas this, I'm like, I don't know. Okay, I know what it's going to do, but if there's a lot of them, then it kind of loses me a little bit. And you'll see a lot of crazy coding like that. So that's inline functions. So why use an anonymous inline function expression? So you can use this anonymous inline function expression. That's a lot to say. It might seem like not very useful at first. Why define a function that can be used only once? You can't even call it by name. So you would use these with callbacks. So yes, we haven't got to Node.js yet, but you can have callbacks in JavaScript. So if you're not going to use them elsewhere, meaning you're just going to use them one time, or they're only going to be used in that way, then you could store them. You could store them in a variable and give them a name and pass it around. However, the function is not going to be reused, so you save lines of code, right? So if you have something very simple, and maybe you don't want to go through the effort of giving it a name, maybe you just wanted to, you had a very simple function that, just did something like this. It just console logged, loading page, I don't know, or starting whatever, X calculation, right? Something like that. It's so trivial that maybe you don't want to go ahead and do any more work than that. Maybe you just want to pass it in that way. That's fine, because it'll only be used in that manner one time. So you may not want to pollute your namespace with something so trivial, and that might be a way why you might want to do that. Otherwise, if there is something that makes sense to you, that has meaning and can be used, then it's better to give some other kind of expression, give it a name. But it's a big mouthful there. Anonymous inline functional expression. Functional expression recap. We're near the end of this, so hang in there. Functional expression recap. When a function is assigned to a variable, the function can be named or anonymous. Use the variable name to call a function defined in the functional expression. This is something anonymous functional expression. Do something. This is the function. It does y plus 1. This is the name functional expression. So it has a name, add 1, so it's named. But really, in the end of the day, it does the same thing. I'm going to be interrupted, guys. Hold on. There is a Roblox emergency at my house, trying to get people set up with their gaming. Right, so I mean, it really doesn't matter here. At the end of the day, they both return 6. It's 2 different ways of doing it. This one's anonymous, this one is named. Just so you know, if I ever ask a question, what's the difference between anonymous and named, you would know. Functional expression recap. You can even pass a function into another inline. We already talked about this one. This pattern is commonly used in JavaScript. It's helpful for streamlining your code. If it's something very small and you don't really care to use it again, you can simply pass it inline. So we already went over that. So that's what an inline function is. All right, so I had some videos there, and it looks like the audio is not going to work right now. I can try to do my setup. Okay, so we got to the end of that. That's a lot to take in. So I'm going to upload the lab momentarily here. It's going to be on, give me 1 second here. I'll upload it. Bear with me. All right, so this is up. Lab 10 exercises. So this is going to be on function expressions, and we're going to do some math. Not we're going to look at some built-in objects, but you can work ahead. So these now, when we're getting into some scripting and programming, there's more logic involved because it's not a UI. I feel more comfortable with this stuff, to be honest. UI styling is not my thing. I aim to get better, but it's my weakest aspect of it. So when we start getting into programming, you need to start thinking about logic and how things work. They're like little puzzles, right? So this is a little bit of a different lab. We're going to kind of try to solve, there's not as much step by step, but it's kind of, you're going to be given some instruction, and you're going to try to go build some small little functions, right? So this one, and again, we can use this REPL, and you can build your functions in here, and then you can just, copy paste your script inside of a JS file, right? We can just, instead of doing this whole piece here with the script, we can eliminate that. We can just, we can create a script here, test script.js, and we can add our code in there. We could pretty much run it in the REPL, and once we know it works and we invoke it, we can just submit this, right? Just like that, because it's going to be a JavaScript script on its own. So it kind of eliminates the browser in a sense. For now, we're talking about logic, so we can just work on this, and you run it, execute. By all means, if you want to do it the other way, I'm perfectly fine with that, if that is more familiar to you, but it's a lot of extra work. So this one would be exercise 1, given, yes, go ahead.
The format for these exercises, do they have to be in JS format or a simple text format?
JS, so I can, if you're writing JavaScript, number one, your compiler here, your Visual Studio will actually format it nicely for you, and actually you can see some. You can run it. I haven't taught you Node.js. You could normally run it from here, but yes, you can do it as a JS. If I save this as a text file, it's going to be, it's going to look like this. For me, looking at it, if I see something like this, then I really got to figure out what's going on in there, because then it's, let's see what this looks like. No extension, I don't even know. It'll probably not plain text. If it was plain text, what happens here? It kind of formats. I mean, it's not wrong, but try to get in the habit of saving it as .js. I mean,
yep, we'll do that. No problem. Thank you.
Yes. All right, so this one is kind of, given 2 numbers or less. So we're going to create a function here that compares, a number, takes a number, and returns true if it's less than 0 or greater than 0. So that's kind of a function you call it. That one's kind of straightforward. Next one would be football points. So you give a functional expression. Remember expression, 3 parameters, numbers of wins, draws, and losses. And you need to go in this manner. I'm giving you the output, and you need to figure out that calculation, right? Wins gets 3 points, draws gets 1, losses 0. So you're going to do some calculations in there, and you're going to be able to call them. So it's more of a arithmetic logic kind of thing. This one would be theater admission. Have a guest, you check whether he can watch some +15 rated movies. So you want to check the person's age, if they have parental supervision, and then you kind of, true, false. So they get a little harder as we go, but let's go there. Let's start with that. I'm going to try something new. I don't know how it's going to work. Again, it's another experiment. We will see how it works.